Well, greetings out there in YouTube land, and welcome to part 2 of our epic video series featuring the scratch build of an amplifier that Fender never built but should have, the Vibro-Champ Reverb. In this part 2 video, we will finish machining the chassis, install all of the components, and begin the wiring of the circuit. For those who are trying to interpret and read schematics, I will try to tie together the visual manifestation of the circuit as I construct it and tie it to the symbolic representation in the schematic. I hope to get the chassis finished, all components attached, and at least half of the wiring completed in this part 2 video. So without further ado, let's get started. Step 1 in machining the floor of the chassis will be to install it in the cabinet up snugly against the rear panel. Then we will use a real sharp punch like this, run it down, straight down through the hole, making sure that it is perfectly vertical in both directions, and then tap with the hammer to dimple the floor of the chassis and then drill out the holes slightly larger than the chassis mounting screws. And here we have the 4 holes. I've chamfered the top and the bottom to get rid of any sharp pieces of aluminum, and also to facilitate the chassis mounting screw finding the hole. Okay, now let's reinstall this back in the cabinet and see if the screws line up. And with a very minimum of hunting with the tip, we find the corresponding holes in the chassis, and all 4 screws pass through them quite nicely. And although we're not quite ready to machine the rear of the chassis, I'm going to put some felt tip marks here to delineate the part of the rear of the chassis that is covered by the rear panel, just so I don't foolishly try to drill any holes or install any components in this area or this area of the rear of the chassis. Better safe than sorry. Now, next I'm going to lay the cabinet down on its face, leave the chassis in place, remove the back panel, and set the speaker in place. And we're going to determine if there's any areas here in the floor of the chassis where clearance with our speaker is an issue. And I think that's probably only going to be right around in this area right here. So let's draw a line to show where that area exists, and maybe make a few measurements to see what kind of clearances we have between the floor of the chassis and the speaker basket. I attached some white tape to the chassis to make the lines and numbers a little clearer. And you see from the magnet we have about 3 3/4 inch space. To the top of the basket it's about 2 3/4, and then it gradually decreases down to about 1 inch from here, and about a 1/2 inch to the bottom of the chassis here. And then along this line at the bottom, it shows that we have the edge of the speaker and nothing should be past this line, and I can't imagine that anything would ever need to be. This is my initial sort of rough layout that I envision for the components on the floor of the chassis. This area right here is off limits because it's either directly above the speaker baffle or the grill cloth baffle. That means that the power transformer can be put back here in this corner as far as possible from the amplification tubes. We'll have the rectifier right here and the 6v6 right here. The output transformer could be aligned at 90 degrees axis here with the power transformer and can easily communicate with the 6V6. The rectifier tubes here so that the wires, the AC carrying wires running to it will be very short. The 312AX7s can be grouped over here at a safe distance from the power supply. I envision that inside the chassis right along here will be the electrolytic filter caps. And finally, I'm thinking the reverb driver transformer can be over here and still communicate with the reverb tank, and I'm thinking that the jacks, the RCA jacks for the reverb tank, will probably be right here. I kind of like the idea of the shielded cables to the tank coming straight down to the tank instead of coming out around the back and all, where they're, I think, rather vulnerable. The speaker outputs, both 4 and 8 ohm, can go on the rear of the chassis. We'll have the fuse, the negative feedback switch, and I'm having to think if there's anything else. I think there's plenty of room back there for it, but that's kind of the way things stand now. The transformer's nicely spaced, power supply isolated from the amplification and output tubes. I think this is a pretty good setup. And once I get it mapped out where everything is really square and properly spaced, I'll probably start drilling and cutting the floor. Now it's time for one of the more challenging jobs, I think, in machining and preparing a chassis like this, and that is the installation of a recessed power transformer. Now I'm going to place it right over here where I'm a little bit inboard from the chassis mounting screws, back a little ways from the speaker baffle so I get air around the transformer to cool it. And I made a sort of a stencil here of the hole required for the transformer and for the 4 mounting studs. So I'm going to position this, draw around it, then I'm going to drill out the radiused corners and then cut in between them with a saber saw, and then finally drill the 4 mounting holes. Using my template, I have drawn the inside opening, which will be the part of the chassis that has to be cut away so that the transformer can recess into it. And I will also now find centers to drill the holes here that have the proper radius for the curvature of the transformer. Then we'll use our saber saw, remove it, and then I can proceed to drill the holes for the transformer studs. Okay, I've drilled the 4 corner holes. Now saber saw to make the straight cuts. Then naturally a little bit of filing to smooth things up, and we'll check for clearance with our power transformer. The hole is cut and cleaned up with a file. The transformer seems to fit just fine. Now it's time to drill the mounting stud holes and make sure that it fits in well. Now, using a bit that's just slightly larger in diameter than the transformer studs, I drilled the 4 holes. We'll see if the transformer will fit in now. It generally does require a little more filing, kind of oblonging 1 or 2 of these holes to get it to fit in just right. We'll see. As usual, 3 of the 4 holes line up beautifully, but this one, the hole will have to be moved a little toward the center of the chassis. Okay, so I've got a little filing to do, and then we'll see if we can't get it to fit. The holes have been slightly oblonged up here at the top. And let's see if the transformer fits in. Perfect. Just fell right in place. So that much is done, and I can breathe a sigh of relief because I never really look forward to installing these recessed power transformers. Now let's move on to the rest of our chassis component holes. After giving it a whole lot more thought, I've revised my layout for the circuit components. I had to reconsider that with the upper backdoor panel in place, if I put the rectifier and 6V6 here, they would be really shielded from any ventilation and heated by the power transformer, which didn't seem like a good setup. So I've moved them out here where they're spaced from other components and air can circulate. I think it'd be a real good idea to put the output transformer right in centrally located. Remember that the wire is going to come up here for the 4 and 8 ohm speaker outputs, and we will be communicating between it and the 6V6, which I think I'll put here closer to the rear of the cabinet. The 12 AX7s will be in the same position I had originally anticipated. They don't produce a lot of heat. I'm going to keep them as far as possible then from the power supply and the rectifier. The reverb transformer can be set back here. It will then be connected downward to the tank and also to the reverb driver 12 AX7. On the back here, the fuse holder will go right here, which positions it very close to the power transformer and the power supply. Over here will be the RCA jacks for the foot switches and for the reverb tank. I think I'm going to go back to putting them on the rear here of the chassis. Instead of trying to reach up in here with a mirror and plug them in, I'm going to go ahead and put them in their normal position right back here. And we will also have the 4 and 8 ohm output for the speaker, both the cabinet speaker or the remote speaker. And once again, they'll be very close to the output transformer. So I think this arrangement makes good sense, and that's the way I'm going to proceed. And I forgot to mention the power cord is going to come out right here, drop straight down and out. I think this is a perfect place for it, and it's extremely close to the on-off switch, the fuse, and the power transformer. I have the pilot holes here for the 3/4 inch step bit to open these up to be the right diameter for the 12 AX7 tube bases. Over here I have the pilot holes for the 6V6 and the 5Y3, and I will need a 1 3/16 inch step bit to open them up to allow for the socket to fit in properly. I have the step bit here mounted in the drill press at its slowest speed, and the beauty of these step bits is that when it opens the hole to the proper size, it also chamfers it with the slope here that leads up to the next larger diameter. So it's kind of a nice touch. It really serves two purposes. So now let's open up the 3/4 inch holes, which will be this portion of the step bit right here for our 12 AX7 tube bases. The 3/4 inch holes now have been created to allow our 12 AX7s to pass through. Now let's use the step bit to do the 1 3/16 inch holes. For this we'll be using a much fatter step bit, but it's all chucked up and we're ready to go. And we see that the holes now allow for proper mounting of the 5Y3 and 6V6 tubes. Our next chore will be to drill the either screw or rivet holes to secure each of the two bases to the chassis. You have to align the bases so they're perfectly square and exactly the same rotation. You notice that the missing socket hole is in exactly the same position on all three. Now I'm going to mark these holes and drill them. The holes have been drilled, and then you double check to make sure that they line up properly. And if they don't, you can use a small rat tail file to oblong them a tiny bit. But those look like they line up. Next we have to drill the holes for the screws to mount these two tubes. I marked each hole with a felt tip pen and then dimpled each spot with a sharp punch so that the drill would not wander around while I was trying to get it to start. Although these sockets will be mounted from beneath the chassis, you still need to check to make sure that the holes line up with the holes in the tube base. So that's looking pretty good. I think we've done the floor of the chassis. Now we need to turn our attention to the rear panel. Now for the final step in the preparation of the floor of the chassis, we have to drill the holes for the passage of the wires on these surface mount transformers. And the wires come out, half of them on one side of the transformer, half on the other. So there'll be two holes here and two holes for the reverb driver. And of course, before we run the wires through those holes, we'll have to use grommets to protect the wires from rubbing on the metal. But the grommets won't be added till after we've decided what to do with the finishing of the chassis. For now, let's drill the holes and then we'll move on. The wire passage holes have been drilled for the surface mount transformers, and I fitted grommets to the holes to make sure that they would fit properly. Okay, so I believe now that the floor of our chassis is finished and we're ready to move to the rear panel. It occurred to me before I start laying out this rear panel that it's very important that I don't install any components that are going to be interfering with the wiring or components in the floor. So I started constructing my power supply here. I have the pilot light, the on-off switch, the 6V6 and 5Y3. I have the power transformer in place, and then I decided, instead of putting the filter caps over here near the controls, I built like a second story of terminal strips here, which will allow me to have the three 20 microfarad electrolytic filter caps elevated here with the internodal resistors, creating the power rail for the amp. And then I'll have space underneath for the power cord to come through and interact with the on-off switch and the fuse, which will probably have to be moved over just a bit so that when it comes in it doesn't interfere with the tube socket. So see, this is something that I gained by setting this up first. Instead of putting the fuse in like over here where it would interfere, now I know I can put it here and it will have plenty of room inside. So now I can drill a hole for the fuse holder where it will protrude inward right here between the 6V6 socket and the output transformer, and a hole underneath here for the AC power cord where I'll bring it up, bend it over with a wire retainer and let the wires go to the proper components. The power cord now will come up through the back left floor of the chassis, go through a steel clip that will not allow it to be pulled out, comes around to the power switch. the black hot wire in the AC power cord will go to the on-off switch. The other lug will come over to the tip of the fuse holder, and the primary wire, one of them from the power transformer, will connect right here to the fuse, and the other primary wire will connect directly to the white return wire in the power cord. The green ground wire will be securely grounded to one or the other here of the lugs of the power transformer. After that, the power rail will be constructed somewhat elevated here between these two terminal strips with the internodal resistors. The end result being that the entire power supply, rectifier, and output tube will all be located down here in probably, maybe a third of the chassis, whereas all of our preamp tubes and other sensitive signal wires will be completely separated up here with plenty of room and space, and will be protected against a 60 cycle hum, hopefully. Well, I've marked off where the rest of the components will go here on the back panel. I've used a center punch to position the drill bit. We've got the 4 and 8 ohm speaker outputs. We've got the NFB switch, which is going to be a small, kind of compact switch. I'll show you in a minute. We've got the reverb in and out, and we've got the foot switch, tremolo, and reverb. Now it's time to drill pilot holes, and then all of them happen to be 3/8 inch holes. So I'll be right back once they're drilled. The 3/8 inch holes are all drilled. This will be 4 ohm, 8 ohm speaker output, NFB switch. These two will probably be for the reverb tank in and out. These two will be for the foot switch, reverb, and tremolo. I've got a space right here that's blank, which is kind of necessitated by the fact that there are tubes right behind it, but maybe I'll make a giant Underwriters Laboratories sticker here, something like that. This gives me some room to be creative. Okay, but anyway, the rear now of the chassis, the rear control panel, is finished. And I think the positioning is really good because you have the 2 speaker outputs right beside the output transformer. We have the NFB switch between the output transformer and the triode cathode. And we have here our reverb and foot switch inputs right next to the tubes that they will affect. Now it's time for the final step in the preparation of the chassis, and that is to install a whole bunch of terminal strips to assist in the wiring of the tubes and all the controls along that front panel. I'm going to have to mark proper holes and drill 1/8 inch holes for the rivets that will hold the strips in place. And terminal strips are like horsepower and toilet paper. It's always better to have more than you need. I believe the chassis machining is finished. It required a total of 70 holes to be drilled and cut into the aluminum. I have all my terminal strip mounting holes figured out here and drilled. So now I'm brushing it with a Scotch-Brite. I think it's time to try to figure out how to finish this. Should it be jet black or a silver face? I'm not exactly sure yet. I'm going to have to think about it for a few minutes, and I'll be back with you. I've been given a whole lot of thought as to how to finish this chassis, and to be honest, in the past, spray painting them has been no fun at all because it's very fragile. The paint has a hard time attaching to the metal surface. Even if I use etching primers, So my strategy is on this one to try something different. I'm going to have contrasting finishes in that I have polished this up pretty much like a chrome or a mirror on the faceplate, and I'm going to mask off sections of it and bead blast so that I get a frosted and polished contrast pattern on the front. We'll see how that turns out. If it's great, well, and so be it. If it's crap, then I'll try something else. Okay, so I've been doing some polishing. I've got a little more to do, and then I'll start masking. Okay, I have the final polish completed. Now it's time to start masking. And for those who are interested, I'm using for the polishing a ball door big polishing motor with flannel on one side and a sisal wheel on the other. Okay, here's what I'm thinking. This vinyl tape to protect the polished surface above and below the knobs. The distance here is exactly the diameter of the skirted knobs. And I'm going to have one shiny stripe coming down the centers of all the holes. Now I don't know if this tape can withstand the bead blaster, but I know this can here, this rubberized tape. So next step will be to go into the mighty bead blaster and blast away. Well, I pulled up some tape to show the stark contrast between the polished aluminum and the bead blasted aluminum. I placed the knobs, and that gold stripe didn't last, 3 seconds. Be honest, I'm not knocked out by this. It's kind of boring to me. It looks almost like it's flat white. I was hoping for something to be a little more impressive. One thing now is I can probably paint this, and the paint will probably stick because the bead blasted surface is rough enough to really give the paint something to hang on to. But if I paint it black, I wonder how it's going to look with black knobs on black metal. Of course, that's the way fenders are, isn't it? Maybe I'll try it and see. First step is a couple light coats of this Duplicolor self-etching primer. It's kind of a greenish gray color. I'm going to let it dry thoroughly, and then I'm going to go over it with some black paint, and we'll see what happens. Well, there's 2 coats of satin black and 2 coats of satin clear. I think I'd like to lift the tape and let's see what the contrast looks like. I'll tell you, it looks pretty slick from here. I think that's better than just the bead blasted aluminum. Now, the upper shiny area here will allow me to do my decals that will label each of the controls, and then I think I'll do a clear coat over everything. Maybe a high gloss clear just to see how that works. Well, here's how it looks with the tape pulled. There's a nice contrast really between the shiny black knobs and the satin black background. And when everything gets labeled, I think it'll look pretty snazzy. And I also have a feeling that this paint's going to stay on here. Now it's time to do the rear of the chassis. I polished it, and now I will mask off the top and bottom, and we'll bead blast that central stripe. There's the rear panel all finished up, and I think that when the jacks and switches and other things are mounted with shiny hardware in this black stripe, they're going to really look nice. And then I can label each of them up above in the polished aluminum area. Well, this is the state of our amplifier control panel at the moment. I have the satin black above and below and a 3/8 inch strip here of polished aluminum, same at the bottom, and I have printed the labels out on a clear acrylic sheet that is adhesive on the back, and now I'm going to cut them out with this paper cutter so that the lines are perfectly straight, and lay them in here above and below the components that they are labeling. And here is the finished product. All of the controls labeled, and we still have a nice contrast between the polished aluminum and the semi-gloss black. Back here we have Blackie, who's another one of our feral cats. He's the ultimate tomcat. He's a fighter, and keeps all the other cats out of the yard so that he can eat from his food dish, which I fill way too often for fear of reprisals. Look at that expression. Pretty scary. Just a minute, Blackie, I'll get you your dinner. Here's the rear of the chassis, all labeled. And I think we're ready now to start assembling the components in the chassis, and then to start wiring. Step one is to remove all the masking tape and then go over all of the bare aluminum surfaces in the amp with Scotch-Brite pads to make sure that nothing will interfere with good contact between the components and the aluminum surface. Next, I'm going to gather together all of the significant amount of parts that are going to be attached and interwoven into the circuit of our amplifier. I warn you, this is not a cheap project. Including the tubes, I'm going to say that it's probably around $700 to $750 worth of parts. Okay, so not a cheap hobby, but I think in the end, or at least I hope, that it all turns out to be worthwhile. I think step one is to install the power transformer into the chassis, and then we will move from there to installing all of the components in the power supply and wiring some of them. Okay, so let's get started. Fortunately, it fit just perfectly, so let's flip this over and install the components that are connected to the studs, and then we'll put the nuts and lock washers down that secure everything together. Okay, the 4 nuts are secure, and we've also included that offset terminal strip that's going to be for our filter capacitors. Now let's rivet in the opposing terminal strip for our filter cap elevated array. Well, the second terminal strip is riveted in, and I've installed the pilot light and the on-off power toggle. I noticed that the terminal at the bottom of the toggle was very close to the chassis, so I've glued in a piece of thick insulating board to prevent any contact between the AC power lug here at the bottom and the aluminum chassis. Well, the hideous mess has begun. Once the chassis assembly starts, the mess does too. Now I have the primary all wired. Power cord comes in with a clamp here to keep it from being able to be pulled out. Come around, the black wire goes to the power switch. That black wire is the hot wire. Power switch comes out of the power switch through the fuse and then into one of the 2 black primary wires of the power transformer. The white return wire from the power cord is connected to the other primary lead for the power transformer. The green ground wire is securely bolted down with a lock washer to the aluminum chassis. I know that a lot of you like to wire the fuse first and then the power toggle switch. As I have explained countless times in previous videos, I prefer to wire the switch first. However, you're welcome to wire it any way you wish. Fuse first or power switch first. I've installed the two grommets. Now it's time to bolt in the output transformer. The output transformer has been securely attached to the chassis using number 8 screws, nuts, and lock washers. Now it's time to install the 4 and 8 ohm speaker output jacks so that the output of the transformer can be wired. Well, I've installed the RCA jacks on the rear panel for the foot switch, for the reverb tank, the NFB on-off switch, and the 2 1/4-inch jacks for the 4 ohm and 8 ohm speaker output. You can see that the output jacks are within an inch of the wires that will be connected to them. I went inside and looked up the transformer, and the yellow wire is for the 4 ohm output, green wire for the 8 ohm, and black is for the common or grounded lead. So let's wire those speaker outputs as far as the secondary of the output transformer goes. The speaker output jacks are wired, green to the 8 ohm, yellow to the 4 ohm, and common to the grounds on both. I've riveted in the tube sockets for the 5Y3 and the 6V6. You see the proximity of the 5Y3 to the power transformer, and 4 of the wires that are right here are going to go to it, 2 to the 2 plates of the rectifier, and 2 to the 5-volt cathode. Down here on our 6V6, the plate is going to receive one of these wires, either the blue or the brown. The blue is if we want to have 8,000 ohms of plate load resistance. The brown is if we want to have 5,000 ohms of plate load resistance. The red is going to go to the B plus that comes from our rectifier. So we need to have a short discussion about which is preferred, the 5K or the 8K of plate load resistance for the 6V6. We see that the rectified high voltage is going to come out of pin 8 of the 5Y3 and come up here first to the filter capacitor rail, and then on up to the output transformer primary. And to see what that looks like here, we see that we come out of pin 8 of the rectifier. This is going to be our filter capacitor rail, and we go directly from this lug here to the primary of the output transformer. We will then decide which of the leads, the 5K or 8K, will connect to the plate of the 6V6. Now, to make our decision about which of the output transformer primary leads we want to connect to our 6V6 plate, let's have a brief discussion of load resistance. There's a formula that I found on the internet that says if you square the B plus, divide it by plate dissipation, you'll get the approximate value. Okay, so I squared 350. Remember the schematic said it'd be around 355. I squared 350 and divided by 12, and I got 10,208, which is 10.2 K. Okay, now let's look at our tube manual and see if that helps us. And we see here that for different plate voltage readings, we get different load resistance, and it's not directly related. We get a higher load resistance for 180 volts, goes down a little at 250, comes way up at 315. So it's hard for me to see that a formula could actually calculate this. But we do see an upward trend, okay, at 315 volts. It has gone up quite a bit, and I'm thinking at 350, which is probably what our B plus will be, it's going to be higher than 8, and it may well be around the 10.2K. Now, our choices, though, are limited to 5 or 8. So what I'm going to do is connect the blue, which is the 8K load resistance wire, because that's the closest to the 10.2K that we have calculated. I hope this makes some sense, and I hope it explains my decision. Here you see that the blue 8K wire is connected to the plate, which is pin 3 of the 6V6. Now this is the 5K wire, the brown one, and I didn't want to just cut it off or let it flop around in here and get in trouble. So I soldered it over here to pin 6 of the 6V6. Now this is an unused pin, and therefore I thought it'd be a safe place to kind of tether the 5K wire. Okay, bear in mind then this does not connect to the tube and will not affect things in any way. It just holds the wire in place. I think it's about time to connect some of these power transformer wires, if nothing else than to reduce the clutter that they create. And I looked up this power transformer on the internet, and I have what the color codes are for all the wires. Now in the past I've started off with the lower voltages, the 275s, and ended up having to go to the higher output. Also, I see here on the Fender schematic that it says that the high voltage supply to the rectifier is 315 volts each, which gets us real close with the 325s. So I'm going to use the red high voltage output to the rectifier and kind of coil up the red and whites and keep them in case it turns out they're a better choice. Regardless of which I use, the red and yellow will be the grounded center tap. We see from the schematic that the red high voltage wires go to pins 4 and 6, which are the plates of the 5Y3. And as you can see, I brought those red wires down here to pin 1, 2, 3, 4, and 6 of the 5Y3. The red and yellow center tap comes around here and is soldered to a lug that is bolted securely to the chassis. This schematic shows us that the yellow wires, which are the 5-volt output, are connected to pins 2 and 8 of the 5Y3 rectifier. You look here and see that I have connected the yellow wires to pin 1, 2, and 8 of the rectifier. And also remember that pin 8 is where our B plus will come out along the red wire, go to our filter cap array, and also to the primary of our output transformer. Now it's time to wire up the green 6.3 volt AC filament supply for our tubes. Notice also that I'm keeping the AC output wires from the power transformer in close proximity, gently winding them when possible so that they will neutralize the electromagnetic field that is generated around each wire. They're out of phase, so they can effectively neutralize that field. I will do the same with the 6.3 volt AC wires. Here are the 6.3 volt green wires coming to pins 2 and 7 of the 6V6, which are the two filament leads. Also, the center tap comes around here and is soldered securely to the same lug as the high voltage center tap. So let's take stock here where we stand. Our power transformer is fully wired, the primary circuit's wired, our rectifier tube is wired, output transformer, and speaker output jack. So I think we're doing pretty well. Now that the left side of the chassis is all wired and assembled, I have installed the three 12AX7 tube bases using number 4 screws and nuts. I think it's time to construct our array of 20 microfarad filter caps. So let's begin right here with the 2 elevated terminal strips. I've soldered in the 3 22 microfarad filter caps. You can see that I ran a common bus wire along the negative or grounded leads and then ran it over to the same ground that I'm using for my ground wire from my AC power cord and for the center taps of the 2 windings, the 6.3 and the high volt winding in the power transformer. Next, I'll need to run the internodal resistors between each of the positive ends of the electrolytic caps. According to the schematic, the first one is a 1000 ohm 1 watt resistor. And we see here that I've installed a 1000 ohm 2 watt fireproof resistor between the first and second filter caps. Now we see that the next internodal resistor is 10K at 1 watt. So we're going to install it between these 2 filter caps. And there is the second internodal resistor, 10K, 2 watt, double what the schematic suggests, and again a fireproof resistor, which is always good, I think, in a power supply. Okay, now we have 3 separate output voltages. We've got the 355 volts that are going to our output transformer. We'll have 340 volts going to the screen grid of the 6V6, and we'll have 320 volts going to the plate of the 12AX7. And that means that we'll have 355 volts right here, 340 volts right here, 320 volts right here. Now it's time to install the 6 potentiometers on the front control panel, as well as the 2 input jacks for the guitar cord. Potentiometers are all installed, and on the bottom input jack, because of the angle of the faceplate, it came very close to the base of the chassis. So I glued in another piece of that thick insulating cardboard to prevent any inadvertent contact. Okay, I think we're ready now to start wiring our 12AX7 tube bases. And to facilitate that, I'm going to rivet in all of those terminal strips that I drilled the mounting holes for. Okay, I have a whole bunch of terminal strips installed, and I think what I'll do is see if I can't use just these, and if I need more, I've got other holes drilled to mount more. But for now, I think I need to install that Reverb driver transformer, and to do that I need to put in 2 grommets in these holes. Grommets are in place. Now it's time to bolt the transformer down to these 2 holes using number 8 screws, lock washers, and nuts. The wires, of course, then will pass through the grommet. The Reverb driver is now securely installed, so let's flip this over and start wiring it. Since the Reverb driver will be V3, we need to have a little chat about a modification that I'm thinking of adding to this circuit. And that is that as we look at my schematic for the reverb circuit. Also notice that I've added a 100K plate resistor here that did not exist in the original schematic that I first posted. I've decided, and with the help of some viewer suggestions, that instead of using a 12AX7 with one triode to drive the tank and one triode to recover, to consider using an unusual tube called a 12DW7, also called an ECC 832. And what's unique about it is instead of two 12AX7 triodes, the pins 1, 2, and 3 connect to a 12AU7 triode, and pins 6, 7, and 8 connect to a 12AX7 triode. Now, the advantage of a 12AU7 in the driving position here is that it's much like the 12AT7 that Fender uses, ganged with the two triodes connected to drive the reverb tanks in the large Fender reverb amps. And the 12AU7 is more of a current tube than a voltage tube, and that would be better as a driver for the reverb tank. So if I'm careful and wire the socket for V3 so that pins 1, 2, and 3 are the driving section, and pins 6, 7, and 8 are the recovery section, then I can interchange the tubes. Can plug in a 12AX7, see how it sounds, pull it, plug in the 12DW7, and see how it sounds. So I'm going to do that, and I wanted to draw your attention to the fact that if you are copying this build and this schematic in specific, then it's essential that the drive section be pins 1, 2, and 3 so that you can exchange the drive tubes. That said, if we're going to wire the reverb driver, the blue wire will go to the plate or pin 1 of V3, and the red wire will go to B plus at a level of around 225 to 250 volts DC. Now, looking at the available filtered DC outputs in the power supply of the Vibro-Champ, I don't see anything that's down around 225 or 250. So to get the high voltage that I need for the reverb driver, I might have to run a resistor off of this wire to bring it down from 320 to around 250, and then use that for the reverb driver transformer. The first 3 pins of V3, which will either be a 12AX7 or a 12DW7, have been wired. Pin 1, which is the plate, comes from the blue wire of the reverb driver. Pin 2 is the shielded signal input from the reverb intensity control. I shielded it because of the length that it has to travel, and also reverb signals. A lot of times when people turn on the reverb in their amp, it's noisy, and that's because of all the exposed wire carrying very sensitive signal, music signal information. So I shielded it to try to cut down on that noise. Pin 3 is the cathode bias resistor to ground 1.5K. The reverb input jack has been wired. Now it's a little confusing because it's the output from the chassis, but they label it by the input to the tank. So this will be the input to the tank, and it comes from our reverb driver. The green wire goes to the hot center pin, black wire goes to the outer shield and ground. I also fabricated a little steel clip here to hold the wires down and away from either of the tubes. So now our reverb driver transformer is wired. Remember, this then was supposed to go to what, 225 to 250 volt DC source, which we will create a little later. Now let's wire the screen grid of our 6V6. We'll go from pin 4 right here, which is the screen grid connection, up here to the second node of our power supply. And it's very clear here that there's the first node of the power supply that went to our output transformer. We go through the 1K resistor, and here's the second node, and that's the wire we're going to run right now up to pin 4 of the 6V6. And there is our screen grid connection to the second node of the power supply. Now, besides the screen grid connection to our second node, we also have a wire running down here to the tremolo oscillator. And we see that it provides the 340 volts to the plate of V2B, and also over here through a 470K resistor to the connection between the plate of V2A and the grid of V2B. Let's go ahead and wire this. When I get through, I'll show it to you. Here comes our 340 volts DC from our second node to the screen of the 6V6. Then it continues on through that green wire down here to pin 6 of V2B, which is the plate, and then through a 470K ohm resistor, comes down here to both pins 1 and 7 that are jumpered. Now on V2B, we see that the cathode goes through a 68K resistor to the wiper of the intensity control for the tremolo. That intensity control is right here, so we'll run a wire from the wiper over here through the 68K resistor into pin 8. I think it's time to construct our oscillation loop. We'll go from the junction of pins 1 and 7 on V2 through 0.02 microfarad, 0.01, 0.01, and then back into pin 2. Okay, and we'll use our terminal strip here to construct it. The 3 oscillation loop capacitors have been installed. We come from that jumper between 1 and 7 through a 0.02 microfarad to a 0.01 microfarad across the back and down through another 0.01 microfarad. Now we need to add the resistors and control connections at each of these junctions. Other than the filament voltage to the 12AX7 oscillator tube for the tremolo, it is completely wired. Let's compare the schematic to the actual wiring of the oscillator loop. We start with that jumper between pins 1 and 7, and that is right here. Then we exit from that jumper through a 0.022 microfarad cap, and here it is right here. Then we will connect a 0.01 microfarad cap and the 3 meg reverse audio speed control with a 100K resistor in series. So we'll start right here. Here is the 0.01 microfarad cap. Then we exit down here with the white wire. We come around to the speed control and we exit with a 100K resistor to ground. The other wire that exits from that junction is a 1 meg wire to the pin 3 of the tube, which is a cathode. And here it is, coming down a 1 meg resistor to pin 3 of the cathode. We also see that the cathode is biased with a 4700 ohm resistor and bypassed with a 25 at 25 microfarad cap. Here is the 4700 ohm resistor and the 25 at 50 volt cathode bypass cap going to ground. And finally, at the end of our loop, after our third 0.01 microfarad cap, we see that we have two exiting wires. One is 1 meg to ground, the other goes to pin 2 of the tube socket. Here is the 1 meg to ground, and under there the red with the orange stripe goes down to pin 2 of the tube socket. So as we can see, it is completely wired. Now for a little change of pace, let's wire those input jacks. As you can see, I have riveted in an extra terminal strip that we can use to secure some of our components. The input jack wiring is now finished for number 1, which is the high gain input, and number 2, which is the low gain input. We see that there's a 68K grid blocker from each of those input jacks that goes through pin 2 into the grid of V1A, the preamp tube. And here we see it. Back here we have the 68K and 68K grid blockers bringing the input signal to this point. Because the signal is very, very sensitive at this point, any noise that's inserted into this will be amplified hundreds of times. So we have to keep it dead quiet, and to do that I have used a shielded cable to carry the signal over here to pin 2 of V1A. And as usual, the shield is grounded at one end but not at the other. Otherwise you're going to end up forming a ground loop and creating the very hum that you tried to eliminate by using a shielded cable. I think this is a perfect place to end our part 2 video in the Vibro-Champ Reverb video series. I'd like to think we got a lot done here in this part 2 video. As promised, the chassis is finished, all the components were installed, and the wiring is over halfway completed. Hopefully in our part 3 video I'll be able to complete all the wiring, get the amp fully functional with any troubleshooting that's necessary. Hopefully there won't be much, and then we can try sort of optimizing the circuit. I'm thinking even try a 6L6 instead of the 6V6, and of course our 12 DW7 in the reverb drive and recovery section instead of the 12AX7. If that sounds interesting, I hope you'll stay with us. I would also like to take a few seconds here to thank all our Patreon patrons and PayPal contributors for their generous support in keeping us on the air and advertising free for another month. As I've often told you, without their generous support, there would be no videos at all. And if you would like to join them in supporting our channel, I will put links in the video description which will enable you to do so. So with that happy note in mind, I think it's time for us to sign off. All of us here in Rusty's workshop, we hope you enjoyed this part 2 video and are looking forward to part 3. If so, we will see you soon in the very near future. Thanks for watching. Bye for now.